lunar science aspects from Chandrayaan 1. And Dr. T.P. Das yesterday would have covered nicely the relevance of moon and the scientific aspects to be explored with respect to the moon. So I'll be touching upon some of the interesting results from Chandrayaan 1 in this context. And before starting the lecture, I would like to thank the thank SPO and organizers for this opportunity. And as a person who has worked with Chandrayaan 1, it is always an excitement for me to talk about anything related to, like, mostly the science related to Chandrayaan 1. So, and I thank for this opportunity. So now coming straight to the lecture. So today, basically, although some aspects have been covered earlier, I would like to, I have kept some points for a continuity to my talk. So only those areas I'll be touching upon. So as we know, Moon is a natural satellite of Earth. And then I have put the Moon here because Moon is a general term for any natural satellite of any planetary body. So for us, Moon is very special. So that's why the Moon. And now Moon has been explored in recent times by missions like from Indian missions itself, from Chandrayaan 1, Chandrayaan 2, and Chandrayaan 3, and of which this talk is on Chandrayaan 1, focusing on the outcomes, basically the breakthroughs from Chandrayaan 1. And this is the Chandrayaan 1 payload configuration. So of these, there are 11 payloads addressing the different aspects of Moon, which we can revisit slightly later. There are certain names associated with each payload. So when we discuss the results from these, we can again once come back and see where they are. So these are now the acronyms, which they stands to explore certain aspects of Moon, like the surface, atmosphere, and then how Moon interacts with the environment, and similar what is there on the surface, and these kind of aspects. Now, what we knew before Chandrayaan 1, we can say, like, grossly about the Moon. We know about Earth, or we feel the planet where we live, which is the Earth. And Earth has over the time now, we very well know that Earth has a thick atmosphere, which is composed of nitrogen, oxygen, carbon dioxide, etc. And then, although we don't really feel the magnetic field, we certainly see aurora, which is linked to the magnetic field. And nowadays, we hear a term called space weather. That is also again linked to the presence of magnetic field on Earth. So Earth has, although we cannot see visually directly through manifestations like aurora, we very well know that, and through measurements now, we very well know that Earth has a magnetic field which is dipolar in structure, north-south dipole in structure, and which is substantial, or we can say its magnitude is roughly 35,000 nanotesla. And now coming to, in terms of nanotesla, now coming to the Moon. Now Moon, compared to this, Moon looks a bit dull in this image, which is a visible picture. And what we know about Moon, grossly we say, Moon has silicates and basalts on its surface, and it has an atmosphere, but it is not very thick as Earth, so we call it as an exosphere. And the base of the exosphere, or the boundary of the exosphere, is the surface of the Moon, so it's a surface boundary exosphere. And then Moon has, unlike Earth, Moon has local magnetic field, which are patches, which I'll be showing later. So which are patches scattered around on the Moon. So we call it as localized magnetic field. And then Moon, certainly, since it is a part of Earth-Moon system, this interacts certainly with the environment, which Earth also sees, like the solar radiation. Then another charged particle flow from the sun, which is called solar wind, and then meteors, etc. So it is interacting with the space environment. So grossly we knew these about the about Moon, but then there were certain breakthroughs which is like which is contradicting, or it is totally new to what we were thinking about how Moon is. So that is what which will be covered in subsequent slide. So most of us are it is popularized, or it is available in popular domain about the presence of water on moon. There are certain areas of moon which are least coming in the common community. So I'll be touching upon those results first, and then anyway, definitely I'll be talking about water also, but mostly some areas which of academic interest also. So first, maybe let us start with the magnetic field. So as I said, moon is earlier classically moon was thought that it is non-magnetic and airless. There is no atmosphere. From there, we were matured enough to understand that moon has a tenuous atmosphere and it is local magnetic field. Now, what more can be contributed, or what more should be known about this that we knew now from Chandrayaan 1? Now coming to the crustal magnetic field, this is what I have been talking about, telling about that moon has patches of this color simply means the strength of the magnetic field. So more this higher the color, like this ranges from orange to blue. More blue means more magnetic field. That way we can interpret. And there are some patches seen. This is the far side of the moon, and this is the near side of the moon. This is the space which we see from Earth, and this is the phase which we cannot directly view from Earth. So this areas, there are more patches of magnetic field, and these are isolated. Again, there are isolated patches of magnetic field. So these are called magnetic anomalies because these are they appear only in certain areas, or say, like a cluster. So that's why they are called lunar magnetic anomalies, as opposed to the dipole magnetic field like Earth has. Dipolar magnetic field, which is of the origin from the core. And these are basically from the lunar prospector measurements, and they are measured at 30-kilometer altitude. So as we go still down towards the surface, the strength will be more. And you can see the strength, like it is maximum is 50 nanotesla. We were talking about 35,000 nanotesla in the case of Earth. So this is several orders lower. So still, so one may be tempted to think, is this magnetic field significant at all? Whether they can do something to the moon? Yes, definitely they can do. That's what we are going to discuss. Now, in order to discuss that, we need to understand the environment which is encountered by the moon. That is a plasma flow basically, and radiation from the sun. So sun is shown here, and as we all know about the radiation part of the sun, which we see every day, we feel every day in our life. Solar radiation at Earth also. Now, something which we don't really feel on Earth, and which we indirectly understand is the solar wind. Solar wind is nothing but the plasma flow from the sun. Like it is basically consisting of ionized hydrogen, which we call as proton, and doubly ionized helium, heavier ions as well as electrons. So plasma is nothing but a medium of charged particles. So sun is composed of plasma, and the plasma emanates out from the sun. So, and it flows through the interplanetary medium, and along interplanetary medium, in the sense it flows out from the sun and encounters all planets, satellites, all whichever there in the solar system. And in order to add to the beauty, there is another component called the magnetic field along with this plasma flow, which is called the interplanetary magnetic field, which is nothing, it is not of interplanetary origin. This magnetic field is the magnetic field of the sun, which is flowing along with the plasma encompassing the solar system. And so this plasma and the magnetic field initiates lot of dynamic processes. So the moon also would see this flow, both the charged particles and the magnetic field. Now moon is in orbit around the Earth. So this is Earth, and this is the orbit of the moon. So moon would see this plasma flow directly for most of the time, and 1/3 of its orbital period, it would see it is behind the Earth. So it would see another region of plasma, because Earth has, as I showed earlier, Earth has a magnetic field. So when this charged particles comes and reaches near Earth, as you all know, this charged particle and magnetic field, they interact. And in addition, there is one magnetic field component also here, and they cause a change in geometry, we can say, of the Earth's magnetic field, or and it forms like an umbrella, or the environment of the Earth. There is a boundary which forms like an umbrella, and this is called the bow shock. And the solar wind, this plasma flow get perturbed or get disturbed and move around Earth. So it doesn't, solar wind flow doesn't directly hit us, basically the humans on Earth. That's why in real life we don't really feel its presence, but it manifests in several different ways. So because of this change in properties, this plasma in this region will be different than what we see is the direct solar wind here. So moon sees two different plasma regimes, or two different environment, we can say broadly, during its passage through in one orbit around Earth. Now, what we thought of moon when it interacts with the solar wind, this is what we call as conventional picture. Conventional picture is that, okay, moon see two different plasma regions, that is okay, but what moon can do this to this plasma, or what this plasma can do to the moon? Was thought that, initially it was thought that moon simply absorb these charged particles. It is like a sponge. It absorbs all these particles. So there is complete absorption. And so on the night side of moon, this is the day side where it sees this all radiation and plasma. And on the night side, there is simply, it has to be a void. There is a flow, fluid which gets absorbed, and then naturally on the wake side, there will be a void region. So this is what people thought that moon is like. This is the place where Chandrayaan-1 really broke this concept. Through one observation is that solar wind is not really, it is not like a sponge. It's not totally, it absorbs all the particles. Actually, the plasma interacts with the surface, and they undergo, because these are charged particles, certain fraction of them get neutralized and then come back to space as neutrals, that too with a higher energy, which is called, because solar wind plasma is typically, they are energetic. They are coming with a velocity of something like 400 kilometers in 1 second. They travel with that speed. So their energy is typically around 1 kilo electron volt. So that kind of particles, they undergo charge exchange and then comes back as neutrals, which are energetic. So they are called energetic neutral atom. And the fraction is not small. It is something like even as high as 20% of these particles comes back. So this shows that energetic neutral hydrogen atoms map. So we can see that this colors indicate the energetic neutrals which are coming back, which is called a reflected hydrogen flux, is written here. So as a color as well as the length of the arrow indicates the flux, or basically the number. So we can see that through this is shown like pole to pole, because Chandrayaan-1 is a polar orbiter. So during its traverse, it has measured this. So we can from here we can see that throughout an orbit, it sees this energetic neutral atoms, and they are more concentrated higher near the equator region, because naturally this is a curved geometry surface, and most of them they directly hit the equator region. And so this is an indication that there's scope for more processes on moon. And not only that, solar wind is considered as one of the agencies for implanting several elements on moon, and even for the formation of water, because this solar wind supplies hydrogen, and that is one component in the water, H2O, hydroxyl ions, OH. So, and not only that, solar wind has hydrogen as well as other heavier ions also, which contributes to, again, moon surface, and then eventually escape and contribute to moon atmosphere. So this way, solar wind is an important agency. So this kind of a process has implication on many other aspects of the moon. Now, another result is, now we have found energetic neutral hydrogen atoms. So now, earlier we talked about there are patches of magnetic field on moon. So like Earth, whether these patches of magnetic field can, like what I showed earlier, these patches of magnetic field, whether they can stop the solar wind flow and divert them and form like an umbrella-like structure in the case of moon. This seems to be very unlikely, isn't it? When we see this, the magnitude, something like a few nanotesla compared to thousands of nanotesla on the Earth. So this was something which people have been debating about, but Chandrayaan gave a direct evidence that this is possible. This is called a mini magnetosphere. And then small scale magnetic field on moon can form an umbrella like structure similar to that of Earth. Umbrella is like used to for easy visualization. So it's not really scientific. So please take in that sense only. So this kind of a shield, we can say it is something like a shielding, that kind of a structure. It is possible to form on the moon. So this shows such a map. This right side is basically an albedo map, and if you have to concentrate on this map, where the center, there are two circles in here. The center is the center of the magnetic anomaly region, and this is the surrounding region. We can see that there is a ENA. This color is indicating the ENA. It is related to the ENA flux, like neutral, energetic neutral hydrogen atoms coming out. So whenever there is magnetic field, this neutral hydrogen atom flux is reduced. Why so? Because these particles are not allowed to directly impinge on the moon surface, because magnetic field prevents their entry. So that means magnetic field is able to stand off the solar wind and thereby forms a mini magnetosphere. This solar wind particles get deflected around the magnetosphere, and that's why here we see a higher flux. So this is a totally new idea that such a small scale magnetic field can really form. This is another view of the same. This here we can see how this is on the moon. This is from one magnetic anomaly region. Later, this has been extended. The study has been extended to different anomaly regions and found that this is possible over different anomaly regions, and it depends on certain parameters to happen. Now, so since this energetic neutral atom is a good tool to study such processes, if we construct a global map, we know about the normal albedo map where we see the in terms of radiation. So where it is dark and bright region. Suppose we construct an ENA albedo map, like how much is the impinging flux, solar wind flux to how much comes back as neutral atom. Such a quantity if we define, and then if we plot them, this is the map. This is for the global map on totally on the moon. So if we see that there are certain regions where this ENA albedo is high and low, and certain regions it is comparatively higher. So this most of this ENA suppressed regions, they are associated with the magnetic anomaly. And global ENA albedo is roughly about 16 plus minus 5%, and it is mostly associated with the magnetic field wherever we see reduced ENA albedo region. So now Chandrayaan has opened an eye to one more technical, one more tool to study such processes, which is the using energetic neutral atoms as a tool to study these kind of processes. Now we talked about neutral atoms. Now what will happen to the charged particles themselves? Now when the solar wind, we got evidence that when the solar wind directly interacts with the moon, that a certain fraction of them, that is something like 1%. We talked about 20% in the case of ENAs. Now something like a maximum 1% of solar wind ions or protons, they themselves get scattered back as charged particles. And these charged particles, okay, it is only 1%. What it can do? It can do much because they are charged particles, so they interact with the magnetic field, and solar wind is a moving plasma with an embedded magnetic field. So when we see from moon's frame of reference, it will have an additional electric field component because of the relativity, because of the moving frame. So this electric field component will affect this charge flow, and then they can be taken to several lunar radius distance away from the moon. These charged particle flow can be seen. So as an example, if suppose they are generated here at some point here, their presence can be detected at a very far distance. In principle, actually people have detected lunar ions even at the distance of Earth. So this is the kind of length or distance these ions are able to travel. So this is another breakthrough. And now, okay, so we know that the charged particle gets scattered from the surface. So whether this magnetic anomaly does something more other than this ENA generation and other than what we know about shielding the surface. Yes, they do also, because charged particle and magnetic field, significant portion, something like 50% of them can they get deflected by the magnetic field. So this is the deflection ratio which is seen here. We can see it is as high as 50%. So there are several population. One is surface scattered particles, charged particle. Now this is another population which interact with the magnetic anomaly and then they get deflected, and all these contribute to the environment of the moon. Now we were talking about, okay, all this will happen when we are telling that the solar wind comes, interacts, and then gets reflected, scattered, etc. from the anomaly from the surface. Now, what will happen? Suppose the sun is here. This is the night side of the moon. What will happen on the night side of the moon? We talked about one conventional picture where we said that on the day side nothing happens. Now we understood many things happens on the day side, and the night side there is a plasma wake region. Is it really so? That is what we are going to see. It is not really so. The wake is, plasma wake is not really a wake. There are certainly charged particles in the plasma wake. There are, basically we have detected protons from Chandrayaan-1. So this shows one such observation. This is the sun side. We can see firstly here, sun is this side, so solar wind particles are coming here, and then just we mentioned about the particle getting deflected from the anomaly. Suppose there is a magnetic field, local magnetic field here, and then the solar wind particles interact and they get scattered and they can access the night side because this is the terminator region. So such particles, after interacting with the magnetic anomaly and accessing the night side region, we have seen from Chandrayaan-1. This is the map where this color, this contours indicates the magnetic field, and this color bar indicates the particles emanating from this, and they are seen on the night side. So this is the orbit geometry of Chandrayaan during this observation. So some processes which happens on the day side which affects the night side of the moon also. So we can see that there is a global impact of these processes on the moon. Now there is another process where we see this one we saw when this interacts with the magnetic field and coming to the night side. Now there is another process where these particles, they directly access the night side. So these are solar wind particles, and which this shows their trajectory. There are some population which are seen on the night side, some charged particles. When their trajectories are constructed, this is their trajectory. So as if like they are coming from the sun. So some particles which are coming directly from the sun, they access the night side. So what could be that? They are nothing but again solar wind particles themselves, but they are directly coming to the night side because they have solar wind. Now we discussed that they have the magnetic field also along with them. So they have a gyro radius. Any charged particle in a magnetic field, it will have its own gyro radius. So the certain particle, and they all are not with coming with a uniform velocity. There is a distribution of velocity, and some particle with the higher velocities, they will have higher gyro radius, and they can directly come to the night side of the moon. So now we find that there are some direct entry also, apart from the surface scattering and magnetic anomaly interaction. Some can easily directly access the night side. Now, what can these plasma do to the moon? Like this plasma population, what we discussed, they can, what we talk about, that they are found at certain altitude above the surface of the moon. Now, whether they would really interact with the surface is the next question. Like, okay, there are some charged particle, okay, that's fine, but whether they can modify something on the surface, yes, definitely they can interact with the surface because these all have energy, so they have their own trajectories. They will interact with the surface and then emit. They can also emit energetic neutral atoms on the night side. So this is a map which shows the we can say the intensity of protons on the night side of the moon. So this is the center of the night side, and we see majority of the particle in the like a ring like a structure, and as we go inside, their intensity is low. This is from Chandrayaan-1. And when we see we consider okay, if there is these particles can interact with the night side surface, because on the day side the source of ENA there is direct solar wind. On the night side only these particles which is coming from different processes are they exist in the night side. So if these particles can also interact with the surface, they can emit energetic neutral atom. So this observation shows, this is the ENA map. This observation shows that ENAs do exist on the night side surface of the moon. Basically these are coming from these particles interacting with the surface and then charge exchange and come back as neutrals. So these are the first kind of observation which throw light that this moon's night side is also very active, and there are different processes which we haven't even thought about, which were considered to be of least significance. So those kind of processes are significant. Now we come to another aspect of the moon, is like what we mentioned earlier before at the beginning of the talk, that in order to understand a planetary object, it is important to understand its atmosphere, its environment, its surface and characteristics. So what we know about the exosphere of the moon. So now we use the term exosphere because it is a tenuous, as shown in the beginning, it's a tenuous atmosphere, and then with the boundary as the surface of the moon. What does it mean? It means that this exosphere is continuously being sourced or fed by the surface, nothing by the but the surface of the moon, by set of processes which are shown here. So this is a schematic which shows this is depicts like surface of the moon. So there are different agencies like photons. These photons are nothing but the solar radiation, photons from the solar radiation, and there are moon is continuously bombarded by micrometeorites, and then what we talked now is solar wind. So what happens when the solar wind photons, when they interact with the surface, they can heat the surface, and then certain elements they get released to the environment, contributing to the exosphere of the moon. That is called, this process is called photon stimulated desorption. And another is micrometeorite vaporization, like when these micrometeorites comes with a significant velocity. So when they impact on the moon surface, in the case of Earth, you may be knowing that many of them, they get because of the friction, when they encounter the atmosphere, they die out before reaching the surface of the moon, Earth. Whereas in the case of moon, because since the atmosphere is thin, these micrometeorites directly bombard on the moon surface, and they heat them and then release certain vapors and certain elements to the atmosphere, and this is another source of exosphere. And this solar wind ion sputtering, now whatever we talk, this what happens to the solar wind particles when they interact with the moon, like they get neutralized and coming back, and they get scattered back, all these, and they interact with the magnetic anomaly. Other than that, when the solar wind protons, they interact with the, or solar wind ions basically, when they interact with the moon surface, they can knock out an element from the moon surface. That is called a sputtering. This process is called sputtering. This sputtering is something which people do in laboratory also. For certain process, surface treatment and all. So such a process happens in space naturally because of the heavier ions, mostly other than hydrogen, there are heavier ions also in the solar wind. So they act as efficient sputtering agents to knock out certain elements from the moon surface. So all these understanding is that these are possible. So now what is the composition of the exosphere? Okay, these processes, after all these happens, and what is the constituents, and what is their quantity, and how they are distributed? These are the questions which one has to resolve in the case of moon. So solar wind ion sputtering is theoretically, it is thought to happen, and the first experimental evidence we got from Chandrayaan with oxygen. Oxygen is released from the moon surface, because moon surface has mostly elements in the form of minerals as oxides. So oxygen is one of the elements which is supposed to be present, and its source is solar wind sputtering. So this we got from Chandrayaan-1. We can see that this is the like as we can say, this is a sputtered flux. How many are coming out as a after sputtering process when we observe from Chandrayaan-1. This is the area where we saw oxygen. Oxygen is supposed to be in terms of mass. This is where we expect to see oxygen. This is hydrogen and this is helium, and these are from the neutralization, and this is from the oxygen sputtering signal. So this is a first observation for the experimental evidence for the existence of sputtering and its contribution to the lunar exosphere. So whenever the detailed analysis has shown that whenever the high helium in the solar wind is high, the sputtered intensity is high. That is naturally because helium is a good sputtering agent than hydrogen, because sputtering is a process where momentum is involved. So mass, whenever an ion with a higher mass, it is a better sputtering agent. So here helium plays an important role. Now coming to the lunar exosphere, other contributions we will see. So there was an experiment called CHASE, which is a part of moon impact probe, which impacted the moon surface. That is what we can just revisit our. I'm sorry that I have to take you back. Yeah, this is the moon impact probe. So as part of this once it reached the around moon, this probe got detached, and there was a mass spectrometer on the moon impact probe, so which measured the lunar exosphere on its way till it reached the hit the surface. So that MIP was released somewhere from here, and CHASE the mass spectrometer is called CHASE. Its acronym is CHASE. So when CHASE measured the lunar exosphere from this point till the MIP impacted the lunar surface. So it is something like here. We can see it is like an altitude change because as it descends down, the altitude from the height of the probe from the surface decreases until it impacted. It could measure certain elements on the in the exosphere of the moon. So one such element is the molecular hydrogen, H2. So the presence of H2, this is a direct evidence for existence of H2 and its variability along the latitudinal region. It covered from, this is the MIP track. We can show footprint of the MIP track. So 20 to 90 degree latitude region, and this is the altitude. This is the point where it hit. So we can see that this there is certainly hydrogen, molecular hydrogen is something like 800 to 900 particles per centimeter cube. This is the kind of density which we see for H2, and they show a latitudinal variation we have seen at higher latitude, and they also a detailed analysis showed they show spatial heterogeneity also. In addition to this, whenever there is surface topography changes, this change is also seen. There are certain changes seen in the distribution. Now, apart from molecular hydrogen, CHASE showed the evidence for noble gases on the moon. So they include argon, neon, and helium. So we can see that again, argon, this is altitude. The scale is the x and y axis are same as I showed in the previous graph. So altitude and latitude, you can see that argon distribution is different. So argon is seen close to the low latitude region and at lower altitude, and this is expected because hydrogen is a H2, it's a lighter element, and it can move once it is generated in the exosphere. It can get distributed faster because it is lighter, and moon's gravity is much lower compared to Earth, and so with a lower gravity body, this lighter elements they spread out faster at larger altitude, whereas comparatively argon is 40 atomic mass unit element, so it is confined to mostly lower altitudes, and but it is distributed over a range of latitudes. So this shows how the exospheric composition varies for different gases. So this is not like a homogeneously mixed gas like we talk of Earth. So with a single distribution. Here different gases are distributed in different ways. Now if we consider neon, another noble gas is neon, we can say that it is mostly seen at lower lower and slightly higher altitudes and at a higher latitude region. And another and this neon density is something like 16,000, and argon is something like 40,000, and density in terms of number density. And now helium, if you see, helium signal was very close to the noise level, but the team could dig out this helium signal from the noise, and it is an upper limit for helium is given. This shows the observation. These points are from the observation, so we can see maybe it is around maybe maximum 1,000. Within that, we should the helium should be present on the moon. So these are the revelation about the lunar exosphere, but the composition. Now the most hot or interesting topic is everyone was talking about will be water on the moon. What is hydration status on the moon? For that, let us come to three aspects. Like water is simply it's not water alone on the surface. There is water on the surface in the form of hydroxyl. There is water in the exosphere in the form of vapor in the exosphere, and there is water in the subsurface in the form of ice. All three findings on from the Chandrayaan-1 indicates presence of water in these three different forms. So let us come to the hydroxyl form, the moon mineralogy mapper on Chandrayaan-1, which by making use of the IR absorption band, which is 3 micrometer, around 3 micrometer, which indicated the presence of OH on moon. So this shows like this whenever their area is, this is a map of OH, and whenever there is brighter region, we can say that there are more presence of hydroxyl ions, hydroxyl, which causes the radical, which causes this absorption. So basically, it's a map of this based on this absorption band. So as we see that, as we go to the higher latitude regions, the brightness, you can see this brightness is more. So which is in turn indicate that there is more concentration of these hydroxyl towards the higher latitude. And it is in turn, it is expected also, or it is matching with what we expect, because moon, it sees the direct solar radiation, the surface of the moon get heated because of the radiation, and the more heating is near the equator, and as we go towards the pole, the temperature falls down. So typically the near the equator, the temperature we can say is around 400 Kelvin. So as we go to the pole, it come close to 100 Kelvin. So when we move close to the colder regions, there is water can get condensed, and there can be more presence of water can be more better detected there. So this is matching with what the scientific world was anticipating, and this shows the albedo map of the same global same area. So so this is based on the remote sensing, and now we have again Chase on the MIP. So when Chase descended through the as part of MIP, it measured water, and so whatever it measures is in the exosphere, so it is in the form of vapor. So basically, Chase gives the mass spectra. The output, the science output from Chase, if we consider, it is basically, it will give you signals. Y-axis we consider as intensity of the signal, x-axis is mass. So in different mass values, you will get a signal. So, and this mass is resolution is typically 1 AMU. So for each one atomic mass unit, you will get a signal which is indicating of certain species. So if you see here, there's peak in the 18 AMU, which gave a hint that there is something sitting at 18 AMU corresponds to, if you consider H2O, that corresponds to 18 AMU. So because atomic mass unit is indication of mass, so the source can be either an atom or a molecule. So H2O is one candidate for the 18 AMU. And if you consider considering this signal, when we plotted this variation of the signal as a function of lunar latitude, we find that this is the observed Chase profile. And whenever this M cube profile, like the surface, wherever the surface is showing less, and in the atmosphere it was high, and vice versa. So that is whenever we have less water content on the surface, they are liberated to the atmosphere and we are seeing in the atmosphere. So they are actually complementing each other. So that this gives the confidence that whatever we see on in the exosphere is really it is coming from the surface. So we have found the component in exosphere also. Now coming to the subsurface part, this is another. There was another technique called where synthetic aperture radar was used, and from this polarization, sorry, from the polarization ratio, this presence of ice was inferred, because there are certain here you can see that there are certain this is the map, and there are certain regions which is mapped which is shown in red color and certain are circled in green color. So these red colored areas are basically fresh craters, whereas this green color are some anomalous craters, it is mentioned, because they got very high CPR ratio, values from these regions, and they are from the inside of these craters. And these craters are close to the or mostly in the permanently shadowed region of the moon. There are some regions called permanently shadowed regions. Unlike Earth has an axial tilt of something like 24 degrees, which was seen in the earlier cartoon also. Yeah, we can see the other than the dipole tilt, Earth axis itself is tilted, geographic south and geographic north pole. So because of this tilt, Earth's poles receive sunlight in different seasons. Whereas in the case of moon, this tilt is something, it is very small. It is something like altogether it comes around 5 degrees. So certain areas of the moon they don't really, at the polar regions, they don't really get the sunlight. And especially if there is a crater in the polar region, the inside of the craters will never get illuminated over the course of time. So for long periods of time. So whatever deposits are there, they will be trapped there. So volatiles are supposed to be permanently shadow. These are called permanently shadow regions, and these permanently shadow regions are considered as a rich source of these volatiles. So it is natural to see more water ice at this close to this permanently shadow, this from the pole, permanently shadowed regions, and this is as we view east from the pole. And so it is gave us again an evidence that there is presence of water ice, especially close to the inside the crater rims and close to the permanently shadow regions and at a higher latitudes. So all these pointed to the evidence of water. That the quantity may be small, but over we are cause of more exploration, we will quantify this better, and then we will have more idea or insight into its variabilities, etc. And now another important point is the, actually one spelling is wrong, it is called buried lava tubes on the moon. Actually there is a terrain mapping camera on the on Chandrayaan, which maps the surface with a resolution of something like 5 meters. So when it mapped the moon surface, there was evidences near the near side of the moon. There were evidences for some structures like these channels, and there are some areas where this is less visible, so it is still have a roof. So whereas this is like a rail, which is like a channel, which is it is just below the surface, it has some depression. So this are basically identified as the lava tubes, and these lava tubes in a way they give us they're substantially longer and wider, and this gives us an idea that in future this tube, the area within these tubes will be protected from the space environment, like high energy particle, high energy radiation, etc. So these are the areas where one can think of a shelter to protect, to get protection from the environment surrounding hostile environment. So this is scientifically important, and this is technologically also it is relevant for any future inhabitation on moon. So now to summarize, Chandrayaan 1 has revealed, most importantly, in a nutshell, if someone asks, we can tell that moon is not passive. That is what we understand. Because moon has a very active environment. It interacts with the particles, it interacts with the radiation, it has an exosphere with the variabilities, and it has water in different forms, and there is lava tubes and much more. There may be some of the results which I could not cover because of the lack of time. So that's why I have written much more. So I hope I could do glimpses of some of the results at least. So now this, if we summarize the dynamic environment, this looks very busy, but whatever processes which we have discussed, all are shown in this cartoon, like magnetosphere, backscatter, sputtered, all processes are there. So this indicates that moon is quite active. So, but our exploration is not over. It continues with more and more missions, because we are yet to quantify many things and yet to understand many things. So our scientific quest continues. And for as a human future inhabitation point of view also, we have to know much more details. Yeah. Thank you.